instance of a class. Instance of a class. Okay. Will it object occupies memory? Yes. Will it object reference occupies memory? Yes or no? It will occupy. Already given, see the notes. Both object and object reference will occupy memory. I given. Okay. What object contains? Data. What object reference contains? Hash code. Object reference contains hash code. It will also occupy memory. I given. Okay. Now, can we create object without object reference? Yes. The type of object is called anonymous object. We can also call unreferenced object. Unreferenced object. Okay. Can we create object reference without object? Yes. What it contains? Null. What is null? Object literal. How many categories of literals are there? 6. What are those? Integer literals, floating point literal, character literal, string literal, Boolean literal, object literal. 6 categories of literals. Okay. Variables. How many types of variables are there? 3 types. What are those? Instance variable, class variable, local variable. Member of a class. Which type of variable? Instance variable. Static member of a class. Inside a method. Local variable, can I write static? No. Outside the class, can I write variables? Outside the class is called global variables. Okay. These all you have seen. Now, memory allocations, I have to explain. Memory allocations. Okay. Now don't write, just listen. Don't write, just listen. Now see, if I write integer x equal to 10, is it valid? Is it valid? No. If I write static integer x equal to 10, not valid. Okay. Now, here integer x equal to y, x equal to 10, is it valid? Yes. This is which type of variable? Instance variable. Static integer y equal to 20, is it valid? Yes. This type, which type of variable? Class variable. Integer z equal to 30, which type of variable? Local variable. Suppose if I write here static, is it valid? Not valid. Okay. Now, 3 types of variables. X is a member of demo class, instance variable. Y is a static member of demo class, class variable. Z inside the method, local variable. Okay. Now, about this variable 3 points, about this variable 3 points, about this variable 3 points I given. Now you can see when memory allocated to instance variable, you see the notes. When memory allocated to instance variable, I given notes. You can see when memory allocated to instance variable, whenever object is created. So this variable memory allocated whenever object is created. Up to that, no memory for that. When memory allocated to class variable, you see the notes. Because I didn't explain that. I didn't explain. Whenever class is loaded. Okay. When this variable memory allocated? Whenever method is called. Okay. Instance variable memory allocated whenever object is created. Class variable memory allocated whenever class is loaded. Local variable memory allocated whenever method is called. Okay. Now, instance variable, in which memory block it is going to be stored. I given that point also. Heap area. Class variable, which memory block it is going to be stored. Method area. Local variable, which memory block it is going to be stored. Stack area. See, first I'll explain that one. See, in a CPU, 2 memories will be there. primary memory, secondary memory. Primary memory nothing but RAM. Secondary memory nothing but hard disk, ROM. Okay. So primary memory, secondary memory, ROM, RAM, ROM only. Okay. Primary memory, secondary memory. Primary memory nothing but RAM. Secondary memory nothing but hard disk, permanent storage mechanism. But RAM is temporary memory. Okay. But all operations are done in RAM only. All operations are done in RAM only. Okay. Now the RAM memory divided into many blocks. One block, nothing but JVM allocated, JVM purpose. That memory called JVM memory. So we are running many programs, multiple programs at a time we can run. See, Notepad is running, Zoom software is running, command prompt will run, Edit Plus will run, so many softwares will run. Okay. So while running multiple programs, that RAM memory divided into number of parts. Notepad purpose some memory, Java programs purpose some memory, like that allocated. So the memory, some memory allocated to JVM. That memory called as JVM memory. That JVM memory again divided into 5 blocks. Okay. There are 5 memory blocks. In JVM, Java Virtual Machine. There are 5 memory blocks in JVM. Okay. First memory block, it is called as heap area. Second memory block, it is called as method area. Third memory block is called as stack area. Fourth memory block is called as native stack area. Fifth memory block is called as PC registers. PC nothing but program counter registers. Like this. First write this one. This one write it. There are 5 memory blocks in JVM. There are 5 memory blocks in JVM. Just note down this all. There are 5 memory blocks in JVM. First one, heap area. Second one, method area. Third one, stack area. Fourth one, native stack area. Fifth one, PC registers. Program counter registers. Program counter registers. There are 5 memory blocks inside the JVM. Heap area, method area, stack area, native stack area, PC registers. Program counter registers. PC registers name, full form. Is it over? Say instance variables stored in heap area, class variables stored in method area, local variables stored in stack area. Remaining these memory blocks, JVM, we'll see further. Present, this information required. Okay. Now you observe a variable that is defined as a member of a class is called as instance variable. A variable that is defined as a static member of a class is called a class variable. A variable that is defined inside a method is called a local variable. Instance variable memory allocated whenever object is created. Class variable memory allocated whenever class is loaded. Local variable memory allocated whenever method is called. Instance variable stored in heap area. Class variable stored in method area. Local variable stored in stack area. These points are given. Okay. Now here, if I run this program, where execution started, that is also required. Okay. First, what will happen? At the command prompt, we'll write Java demo. Then demo class loaded. Because we are writing Java demo. Then demo class loaded. After loading, open brace executed. After open brace, first this is executed. Because class variable memory allocated whenever class is loaded. So at the command prompt, what you will do is Java demo you'll write. At the command prompt, you are going to write Java demo. Whenever you write Java demo, then demo class loaded. So at the command prompt, you will write like this, Java demo. You'll write this demo, nothing but class name. So then demo class loaded, open brace executed. First this is executed. Because whenever class is loaded, class variable memory allocated. So first this line executed. After executing this line, static blocks executed. But in this program, we do not have static blocks. That I'll cover further. After that, main method called. Whenever method is called, local variable memory allocated. But Y allocated, Z allocated. But X is not allocated. Because X memory allocated whenever object is created. Up to that, no memory for X. So before going to this program don't write. First of all, you write this one. Execution priority. Execution priority. First one, class variables. Nothing but static variables. Second one, static blocks. Third one, main method. So execution priority. First one, class variables. Second one, static blocks. Third one, main method. First one, class variables. Second one, static blocks. Third one, main method. Okay. Execution priority. First one, class variables. Second one, static blocks. Third one, main method. So whenever we run the program, first of all, it will search for class variables. Nothing but static variables. Class variables are there. Class variables executed first. Suppose in your program, class variables are not there. Then it will search for static blocks. Static blocks executed. Static blocks also not there. Then main method executed. So in previous programs, there is no class variable, there is no static block. That's what directly main method executed. So whenever I run the program, first it will search for class variables. Class variables are there, that is executed. After that, static blocks. After that, main method. Suppose in your program, class variables not there. Static blocks not there. Main method also not there. Then execution not started. Okay. So this is priority. It is first priority. It is second priority. It is third priority. Okay. Suppose in my program, we have class variable. Now that is executed first. Next, we don't have a static block. Next, main method. Next, this is executed. So first this is executed. Next, this is executed according to this priority. Okay. So we have a class variable, but we don't have this one. That we'll see later. This is main method. So first this is, next this is. But in previous program, class variable also not there, static block also not there. Only this one directly. Okay, like that. It is priority. It is first priority. It is second priority. It is third priority. Now, this is there. That's what this is executed. After that, this is there. That's what this is executed. That is priority. Okay. Now, if I run this program, demo class loaded, open brace executed, static int y equal to 20 executed, main method called, int z equal to 30 executed. But X memory not allocated. When memory allocated to X? Whenever object is created. Suppose I'll create object. This program don't write. Here I'll create object. Demo D1 equal to new demo. This is only object creation syntax, no? I'll create one more. Demo D2 equal to new demo. N number of objects you can create. Now, here some other code that later we'll see. Now, like this, if I write like this, what will be happen? Just observe. If I write like this, first of all, here demo class loaded, open brace executed, static int y equal to 20. It is executed. Here method area. In this method area, y memory allocated. This is 20. Okay. So demo class loaded, open brace executed, static int y equal 20. This 20 executed. This line executed. Memory allocated in method area for y. Okay. After this, main method called, open brace executed, int z equal to 30. That is stored in stack area. That is stored in stack area. So z equal to nothing but 30. After this, now this line executed. But in this line, first of all, new executed. Now, about new, once again write it, because at the time I didn't explain variables. So this diagram don't write, that program don't write. Just about new write it. About new. Note down. It is called as dynamic memory allocation operator. And it allocates the memory to instance variables. At the time I given only variables because instance variable I didn't explain. It is called as dynamic memory allocation operator and it allocates the memory to instance variables. Only this part write it. Remaining don't write, only this one write it. It is called as dynamic memory allocation operator and it allocates the memory to instance variables. It is called as dynamic memory allocation operator and it allocates the memory to instance variables. Over. So the execution process you have to remember. The execution order you have to remember. Okay. Because execution order you cannot write notes. Every program different will be there. Okay. That's what you have to listen with more concentration. Now, demo class loaded, open brace executed, static int y equal to 20 like this. Main method called int z equal to 30 like this. In this line, first new executed. What it will do? It allocates the memory to instance variable x. Where it allocates? In heap area. Okay. In heap area allocates. Here x memory allocated. So first new executed. New is a dynamic memory allocation operator. It allocates the memory to instance variables at runtime. Okay. Just at runtime also write it last. At runtime. The continuation. Instance variables at runtime. It is called as dynamic memory allocation operator, and it allocates the memory to instance variables at runtime. At runtime. Now, new executed, allocated. After this, constructor constructs the object. Constructor constructs the object. So, demo object. Okay, object created. This object referred by D1. Okay, now I'll ask some questions, give me answer. I'll ask some questions, give me answer. Now, what is int? What is int? Data type. What is z? Variable. What is 30? Literal. You already studied, no? How many categories of data types are there? Categories. 2 categories. What are those? Primitive data types, reference data types. Okay? Primitive data types, reference data types. How many primitive data types are there? 8. What are those? Byte, short, int, long, float, double, char, boolean. Okay? 8 data types. What are reference data types? Arrays, strings, classes, interfaces, dash, etc. Many. Okay? This is, remember, how many primitive types are there? 8. What are those? Byte, short, int, long, float, double, char, boolean. How many? What are reference data types are there? Arrays, strings, classes, interfaces, dash, etc. Okay? Now, this is int data type. Is it primitive data type or reference data type? Primitive data type. Okay? It is z variable. It is 30 literal. Literals 6 categories. Integer literal, floating point literal, character literal, string literal, boolean literal, object literal. Okay? That is which literal? Integer literal. Okay? Now, here what is demo? Class name. What is D1? Object reference. Okay? Now, this demo, can I call it as data type? Now my question is, the demo, can I call it as data type? Yes or no? You are getting confusion. 1 minute. Now, demo, is it class? Yes, it is a class, no? Now, what are reference data types? Arrays, strings, class is there, no? Class is there. Now, this demo, can I call data type? Yes. Demo is nothing but class. Class, we can also call it as data type. Is it primitive data type or reference data type? Reference data type. Now, this D1, can I call it as variable? Yes or no? Yes. Whenever this one called as class, this is called as object reference. Whenever this is called as data type, this is called variable. First, don't write diagram, don't write program. This point, write it. Class can also be called as reference data type. Object reference can also be called as reference variable. Class can also be called as reference data type. Object reference can also be called as reference variable. Class can also be called as reference data type. Object reference can also be called as reference variable. Class can also be called as reference data type. Object reference can also be called as reference variable. Now once again I'll ask some questions. Give me answer. What is int? What is z? Int is primitive data type or reference data type? Primitive type. What is demo? Class. What is D1? Object reference. This demo, can I call it as class? Can I call it as data type? Is it primitive data type or reference data type? Reference data type. This D1, can I call it as variable? Primitive type variable or reference type variable? Reference type variable. Okay? No. Now here, this Z contains 30. This D1 contains hash code. Because object created here, that object address mapped into another code. That code implemented with hashing technique. Then that code is called hash code. That is stored in D1. So before writing this program, all those things, first write this point, one more point. Primitive type variable contains data, whereas reference type variable contains hash code. Primitive type variable contains data, whereas reference type variable contains hash code. So further, any primitive type data, any reference type hash code. Further, any primitive type data, any reference type hash code. That point you remember. Okay. Primitive type variable contains data, whereas reference type variable contains hash code. Is it over? Primitive type variable contains data, reference type variable contains hash code. Now, this Z is primitive type or reference type? Primitive type. D1 reference type. So Z contains data. D1 contains hash code. So that's what Z contains 30 like. Z D1 contains this object hash code like that. Okay. Now my question, carefully listen. One more question. Now D1 we can call it as variable. Variable, no? Is it instance variable or class variable or local variable? Now D1 is a variable, but is it instance variable or class variable or local variable? What is that? How do you know that is local? Inside a method. Inside a method. So D1 is a local variable. Local variable, which memory block stored? Stack area. So D1 stored here. D1 stored here. What will be here? Hash code. This object hash code. That's what just I am writing one arrow. The arrow meaning this object hash code stored here. This object hash code stored here. Okay. Now, again, next line. Again, new executed. New. It is a dynamic memory allocation operator. It allocates the memory to instance variable X in heap area. So one more X created. One more X created. For every object separate. For every object separate created. 10. This constructor constructs the object. Constructor constructs the object. This object referred by D2. D2 stored in stack area. This hash code stored here. Now, here in this program, how many objects are there? In this program, how many objects are there? 2 objects are there. For every object, separate copy of instance variable. So that's what X is 2. Here also 1X, here also 1X. If I create 100 objects, how many copies of X created? 100. How many copies of Y created? 1 only. Okay. Before writing this one, this point also write it. Separate copy of instance variable exist. Separate copy of instance variable exists for every object. Only one copy of class variable exists. For all objects. Separate copy of instance variable exists. Separate copy of instance variable exists for every object. Only one copy of class variable exists for all objects. Separate copy of instance variable exists for every object. Only one copy of class variable exists for all objects. Okay. Separate copy of instance variable exists for every object. Only one copy of class variable exists for all objects. So if I create 100 objects, how many copies of X created? 100. How many copies of Y created? 1. Irrespective number of objects, 1 copy. Okay. Now, once again see this program. Demo class loaded. Open brace executed. Class variable memory allocated in method area. Main method called. Local variable memory allocated in stack area. In this line, first new, it allocates the memory to instance variable X in heap area. Constructor constructs the object. This object hash code stored in D1. D1 is local variable, that's what here stored. Again object created. Again one more copy created. That hash code stored in D2. D2 is local variable, that's what stored in stack area. Like this memory allocated. It is just a memory allocation. How to access them, I'll explain. Write this one. Now write this program, write this diagram. Write the program, write the diagram. So separate copy of instance variable exists for every object. Only one copy of class variable exists for all objects. Is it over? Now, when we have to use instance variable, when we have to use class variable, when we have to use local variable. That I'll explain. First, is it over? Now here, note down. Use instance variables. Instance variable. Use instance variables if the values are different for objects. Use instance variables if the values are different for objects. Use class variables if the value is same for all objects. Use class variables if the value is same for all objects. Use local variables to perform the task. Use local variables to perform the task. Same value required for all objects, then class variable. Different value required for every object, instance variable. If any task is there, for that task, local variable. Suppose in one company, 100 employees are there. In a one company, 100 employees are there. Now, employee number for every employee same will be there or different will be there? Different. That means what we have to use? Instance variable. Instance variable. Employee name same or different? Different. Then which variable? Instance variable. Employee address different. Instance variable. Company name then which variable? Class variable. Okay. Salary different. Then which variable? Instance variable. On that salary 10% bonus I want to calculate. Task is there. On basic salary 10% bonus. 10% bonus means immediately it will not come, no? You have to calculate, no? Task is there means local variable. Calculation part is there. Task is there. If the variable depending on other variable, local variable. Bonus is one variable. It is depending on salary. Bonus variable depending on salary variable. That is the local variable you have to use. You have to calculate 10% or 5%. Then you have to use local variable. Task is there. You have to use local variable. Now, I'll use some variables. You select the variable. Okay. Student roll number. Student name. Student address. Student mobile number. Student mail ID. College name. Which variable? Class variable. University name. Class variable. C language marks. Are you calculating? No. Instance variable. Instance variable. C++ marks, Java marks, total marks. Calculation is there. C++, Java, you have to add, no? So total local variable. Like that you have to select. Okay. So by mistake, instance variable place class variable place instance variable. If write, many problems will occur. Suppose 100 students are there. College name, what we have to write? Same will be there. So class variable. By mistake, you written instance variable. Then what will happen? 100 copies created. 100 copies created, no? Actually, one variable enough. 100 created. Memory wasted. Suppose student roll number, which variable required? By mistake, you written class variable. What will happen? For all students, same roll number comes. What do you want? Like that. So that's what 3 types of variable. But here, if we know variables in a proper way, while developing projects, whether instance variable record or class variable record or local variable record, you can select properly, you can write properly. Okay. By mistake, instance variable place class variable place instance variable, many problems will occur. That's what you should learn very depth about object-oriented programming. Okay. Here, suppose 2 projects are there. 2 projects. 2 projects, it is showing same output. Same output. But one project less memory, one project more memory. Reason, variables not selected properly. Then what will happen? It will occupy more memory. More memory means what will happen? Downloading time, it will take more. Suppose example, internet application. Java is especially made for internet. Now, downloading time is more means that application will not become popular. It will be outdated. Okay. For example, if you want to search for some information, which search engine you are using? Google. But only Google is there. Google is there. Yahoo is there. Bingo is there. And Ask GVC is there. Ask is there. So many are there. But which one is popular? Google. But which is second one? No answer. Long gap is there. For Google, crores of requests coming. For other search engine, lakhs also not coming. Lakhs also not coming. For Google, per minute 2.5 crores of requests coming. Other search engines, lakhs also not coming. That's it. Google only number 1. Remaining websites, stop to use. That may be outdated also. Okay. So one category, one application only is become as popular. You observe. Like that, long gap will be there. Suppose you want to download one video or you want to watch one video. Which website you use? YouTube. But only YouTube is there. YouTube is there, MyTube is there, MeTube, so many tubes are there. Okay. But all are using YouTube only. Okay. Reason, fast, performance, memory size, everything will be considered. Okay. Like Google search engine, very quickly it will show the result as compared to all other search engines. YouTube also that much popular. In a videos purpose, YouTube only number 1. And this one, Google only number 1. Like that, one category, one site or 2 sites only will become popular. That's it. Okay. Suppose you want to book one movie ticket. Which one will you use? Book My Show. But there are so many other sites also, no? But Book My Show only top. That's it. One category, one only will become popular. That is, application should be convenient for users. Easiest way should be there. Next, it should occupy less memory. It will downloading very quickly. These are all characteristics. Based on that, it will become popular. Because internet application, 1 second also people are not waiting. Suppose example, you want Core Java tutorial. What you'll do? First you'll open Google. You'll type Core Java tutorial. Okay. So many sites comes. First site, you'll click. It shows loading. Will you wait? They'll go to second website. No one will wait. 1 second also they won't wait. Okay. Because hundreds of sites are there. Why waiting? Second website. Second also slow. Loading. Third website. Okay. If there is no alternative, you'll wait. If alternative is there, no one will wait. Suppose you have a bank account ICICI Bank. You want to do some transaction in online. Which website will open? ICICI only, no other option. If it is slow also you have to wait. Half an hour also you have to wait. Because other not possible. You have an account in ICICI Bank. Then with ICICI Bank website only you can do transaction. Other not possible. If there is an alternative, definitely people will go for alternative. Alternative is not there, you'll wait. Okay, like that. So while developing projects, so many characteristics will be considered. Memory also considered, fast also considered, performance also considered, speed also, everything considered. User-friendly application also. Like anybody should understand that easiest way you have to develop application. Then only it will become popular. Okay, because how to send the mail, how to receive the mail, how to use ATM center, ATM application, how to withdraw money, how to deposit money. Who is teaching? No one is teaching, no. They are learning themselves. That much user friendly you have to create. If website little difficult to operate, that website also outdated. All people cannot understand. All people understandable format, if you develop project, it will become popular. See, no one is teaching how to withdraw money. No one is teaching how to deposit money. No one is teaching how to book a cab, how to book a movie ticket, how to do shopping. They are learning themselves. That much easy, no? What is internet, they don't know. What is computer, they don't know. They are doing online shopping. Right or wrong? What is internet also, they don't know. But what is computer also, they don't know. But they are doing online shopping also. They are booking cab also. They are withdrawing money also. Everything they are doing. Because of user friendly. That type application only will become popular. If it is little bit difficult to operate, that project will outdated. Okay, like that. So many characteristics will be considered. So many characteristics. Okay. Now, use instance variables if the values are different for objects. Use class variables if the value is same for all objects. Use local variables to perform the task. Select properly while developing projects. Okay. Now, next, how to access these variables. Note down. One variable I'll explain. There are two ways to access an instance variable. First one, by using an object. Second one, by using an object reference. There are two ways to access an instance variable. First one by using an object. Second one by using object reference. Just re-login, Pooja, re-login. Because only one person means problem may be your side. If all people voices problem means my side. Re-login. There are two ways to access an instance variable. First one by using an object. Second one by using an object reference. There are two ways to access an instance variable. First one by using an object. Second one by using an object reference. Okay. With object also we can access. With object reference also we can access. Two ways. But when we have to use object, when we have to use object reference, I'll explain. Is it over? Now, suppose you observe system.out.println new demo.x like this by using object. Here new constructor if you write object created with that object x. With that object x. It is object. Demo d equal to new demo. System.out.println d.x. It is object reference. Okay. Now what will happen? Just you observe here. stack area, heap area. Stack area, heap area. Now here you observe demo class loaded, open brace executed, but we don't have a class variables. We don't have a static blocks next to main method. Open brace. System.out.println new dynamic memory allocation operator allocates the memory to instance variable X. Okay, X allocated. Here 10 stored. Constructor constructs the object. Constructs the object. Demo object. Okay. Now object created with that X printed. You will get output here 10. Now second line new again allocates the memory to instance variable. Here also 10. Constructor constructs the object. This object referred by D. This object referred by D. D will be in local variable stack area. Like this. Now this is called anonymous object. We can also call unreferenced object. Okay. Like this. It is referred object. Object is referred by D. Referenced object. Okay. Now my question carefully listen. Suppose this X I want to print once again. Possible or not possible? This X I want to print once again. Is it possible or not possible? Think yourself and give answer. Possible or not possible? How many people answer possible? My question first carefully listen. This X I want to print once again. Is it possible or not possible? How many people answer possible? Okay. How many people answer not possible? Remaining only two options. Possible, not possible. Still you want some time? If you want to think, you can think. But I want response. My question, once again listen. This X, okay? This X I want to access one more time. Possible or not possible? Now give me answer. How many people answer possible? How many people answer not possible? Now, those who given possible, for them one more question, what we ought to write. Those who given not possible, why it is not possible? Only yes or no means you'll give answer. Okay? Only yes or no means you'll select one answer. Reason also. Those who given possible, give me answer what we ought to write. System.out.println. What do you write? Those who given possible. For them one more question. What we have to write? New demo dot X. Those who given not possible. Why it is not possible? Those who given possible, they given answer. Those who given not possible. Why it is not possible? Actually here, this not this X, this is. If you write like this, what will happen? One more object created. That means it is not possible. It is wrong. If you write like this, what will happen? Another object created. But my question, I said many times, this X, I said no. That X only I want to access, I said. That X only I want to access. That X, is it possible to access? Not possible. If you write system dot out dot println new demo dot x, not this x, one more x comes, one more object created. In that one x will be there. So this x one more time, it is not possible to print. Now this x, can I print one more time? Yes. What do you write? System dot out dot println d dot x. Now d dot x, d dot x, d dot x, n number of times you can call. Okay. Now, so suppose I want to access multiple times, many times. Now then which one we have to use? Object reference. Okay. I want to access only one time. Object better. If you use object reference also possible, but memory wasted. This D memory wasted. But if you with object one more time means not possible. Another object created. So here write these points. Use object to access an instance variable. Use object to access an instance variables. Use object to access an instance variable. If it is required only one time. Use object reference to access an instance variable. If it is required more than one time. Use object to access an instance variable if it is required only one time. Use object reference to access an instance variable if it is required more than one time. Use object to access an instance variable if it is required only one time. Use object reference to access an instance variable if it is required more than one time. One time required, use object. More than one time required, use object reference. That's it. Now write the complete program, write the diagram. So this type of logics are object oriented programming logics. Okay. Every point you have to remember. Use object to access an instance variable if it is required only one time. Use object reference to access an instance variable if it is required more than one time. One time required, use object. More than one time required, use object reference. But one time required, if you use object reference, reference memory wasted. More than one time required, if you use object, many objects created. That memory also wasted. Depends upon application requirement. You have to select properly. Selection is your duty while developing projects. Diagram also write it. over. So one time required, use object. More than one time required, use object reference. Like that you have to select. Okay. See, new constructor. If you write object created with that object X accessed. This type of object is called anonymous object. We can also call unreferenced object. About constructor, I didn't explain till. Only constructor constructs the object, one point I given. That is later. Okay. Here object created, that object referred by D. With the D, we are accessing. Okay. Instance variables, how to access you have seen. Class variables, local variables, life, scope, not completed. We'll see continuation on Monday. Okay. Monday we'll see continuation. This continuation we'll see on Monday. See, what is your doubt? Core Java topics. Okay, I'll share in Google Classroom. Class time is 7:30. Yes, 7:30 to 9. 7:30 to 9. Actually, the advanced Java batch is there 6 to 7:30. That's the reason 7:30 to 9. Neha. Yeah, 7:30 to 9. Previous notes not posted. Okay, I'll post. Yeah, initially 7 was there. Actually, initially 7 to 9 was there. 7:30 to 9 I changed. Actually, initially 7 to 9. Initially 7 to 9 2 hours class was there. I changed it to 7 to 9. But just okay, up to 8:45 I'll take. No need to worry. Up to 8:45 I'll take. Just 15 minutes you adjust. Any other doubts? Yeah, your Oracle class 7:30 it will finish. Okay, it is better no? 7:30 can start. Yeah, my mail ID I'll give. Okay, 1 minute. If any doubts are there, you can mail to my mail ID. I'll give a replay for every 4-5 days. Every 4-5 days, I'll give a replay. Immediately don't expect replay because I'll be in a classroom only morning to evening. 5 classes are there. Now this is my mail ID, Neha. You can mail to my mail ID. Assignment I explained. Itesham, Muhammad Itesham. Without explanation, I explained. Ideas also I given. If you don't get, I'll teach. Neha, you can mail to my mail ID. I'll give a reply. Okay. Monday we'll see continuation.